Hello everyone. Now the question is that how do we describe the position of an object in the space? Up to this point, we have seen the Cartesian or rectangular or XY coordinate system. But it is not the only way to describe the position of an object in the space. And this is not always the easiest coordinate system to work in. It depends on the questions. So in this part, I want to introduce another coordinate system which is called polar coordinates. Coordinate systems are really nothing more than a way to define a point in the space. For instance, in the Cartesian coordinate system, a point is given in the coordinates xy. A point is given in the coordinates xy, and we use this pair to define the point by starting at the origin, x units horizontally, followed by y units vertically. So it is the way to define the position of an object in the xy coordinate system. Okay? So what about the polar coordinate system? In the polar coordinate system, instead of moving vertically and horizontally from the origin to get to the point, we could instead go straight out of the origin until we hit the point and then determine the angle this line makes with the positive x-axis. Okay? So we could then use the distance of the point from the origin, which is called radius. So we could use the distance of the point from the origin and the amount we needed to rotate from the positive x-axis. It is very important, from the positive x-axis as the coordinates of the point. So this is all shown by this graph. In the polar coordinates, we write the coordinates of a point in the r theta form. Here r is the distance directly between the point and the origin. Okay? And theta is the angle made between the positive x-axis and that line. So this is theta. So I think you are familiar with these formulas, but let's try to remember how do we get all these formulas. From high school, you remember the Pythagorean theorem, which is a square plus b square is equal to c square. So in this case, we have x square plus y square is equal to radius r square. It is the first equation that we know, and we also know that sine theta, okay, sine theta is equal to what? Y over r, okay, and cosine theta is equal to x over r. What else? So if you substitute these two equalities, you will get y is equal to r sine theta and x is equal to r cosine theta. Okay, so we have two equations here. What else? And tangent theta is equal to, of course, y over x. It is also a noun formula. So we have 4 equalities. We will use all these equalities in the problems of double integrals. So we will, in the next videos, we will solve double integrals in polar coordinates. And I will explain why do we prefer to choose, why do we prefer to solve double integrals in the polar coordinates. Now let's try to convert a point from rectangular coordinates to polar coordinates and vice versa. So question 1, write the point P3 square root 3 in the polar coordinates. So this point is given in the xy axis. Let me draw a simple xy axis here. Okay, this is xy axis or rectangular axis or Cartesian coordinate. So this is the point 3, and let's say this is the point square root of 3. Okay, and this is the point, P. Okay, so we will convert this point in polar coordinates. So let's start. As I told you, I start from the origin to the point P, and we call this distance as r. This is the distance. And what about the theta? Theta is from the initial ray. In this case, it is x-axis. This is the theta. Okay? So, the point 3 square root of 3 is equal to something in the polar coordinate. So what is r and what is theta here? 3, okay. As you see, this distance is 3, right? This is 3. And this distance is square root of 3. And by the Pythagorean formula, r is equal to 2 square root of 3. Square root of 3, square root of 3 times square root of 3, r becomes 2 square root of 3. So, we know what is r now. So, the point 3 square root of 3 is equal to, now r is noun, r is 2 square root of 3. What about theta? What about the angle? As you see, this is a special triangle. This is a special triangle. Let's remember this. This is a. This is a square root of 3, and this is 2a. Okay. In this case, a is square root of 3. So you have what? You have what? What is the angle theta here? The angle theta is pi over 6. It should be pi over 6. Okay? So it is another way to describe the point 3 square 3 in the polar, in the another coordinate system. Let's look at the question 2. We have a simple point here. Let me describe this point. 0 units to the right, it means we stay at the origin. So 2 units to the up. This is the point. This is the point. P. 0, 2. Okay? And we want to convert this point in polar coordinates. So the distance from the origin to the point, is r. So it's obviously 2. R is 2, very simple. And what about the theta? Theta is also very simple. It is obvious. Theta is 90 degrees. So this point is equal to r is 2, 90 degree, pi over 2. What about the third question? In the third question, the point is given in the polar coordinates, and we want to convert this point, we want to write this point in the Cartesian coordinates. So let me draw the related figure here. R is 4, as you see, you have R is 4, and theta is 150 degrees. Okay? What about the position of that point? Let me draw a proper diagram. Now, I think the point is somewhere here. This is the point P. Okay, this is the line R. And the theta from the positive x-axis to the line is equal to 150 degrees. Okay, so this is the R. R is 4, and theta is 150. So if you remember the related formulas, we have x is equal to r times cosine theta, 4 times cosine 150 degrees. Okay, so, and y is equal to r times sine theta. Okay, and we know that cosine 150 degrees is equal to minus square root of 3, and it becomes minus 2 square root of 3. Sine 150 degrees is equal to 1 over 2. Okay, so this point for 150 in the polar coordinates is equal to minus 2 square root of 3 and 2. This is equal to 2. If you substitute, you will get 2 in the xy axis. I think it's enough for the time being. I think now one question remains unanswered. How do we get cosine 150 and sine 150 degrees using the given information? As you see, theta is 150. It means you have 30 degrees here. Okay, this is 30 degrees. If you draw a straight line, this is the 90 degrees. Okay, so this is 60. This is a special triangle. It means this distance is square root 3, and don't forget this is 4. R is given, is 4. So you have 2 square is equal to square root 3 square plus 1. This is 1, and this is square root of 3. This distance is square root of 3. What about this point? This point is minus square root of 3, since you have the minus part, you have the minus side of the x-axis. Don't forget, you are in the minus part, minus side of the x-axis. This is why this point becomes minus square root of 3 and y becomes 1. Okay, so this is why we easily obtain these two values.